Well, welcome to lesson 3 of this Arduino C++ course, and today we're going to be looking at the subject of controlling timings. Now, as always, the code will be available on the lessons page on the Digital Town site, and as you can see, it's controlling timings with if and millis. Just click to download the code. So in our last lesson, we were using Sketch 1 and we were serial printing out our values of my integer, and they were coming out on the serial monitor. So what I've done today is I have resaved this sketch, and it's got the creative name of lesson 3. Now at this point, the sketch is exactly the same. So once again, we've got our serial monitor that we have started up at 9600. I'm going to print out the new name of the sketch, which obviously I've changed in my header, and we're going to leave the rest of this information as it was before. The difference is that I'm now going to uncomment the hello world in the loop. So let's run the code again. Now the code's been uploaded, and if you remember back to lesson 1, the problem was that we see that this information is being printed out at ridiculous speeds, faster than we would ever need. And now the issue comes, how would we control this if we only wanted hello world to be printed once every second? Now usually when you hear someone talk about timings, they will do the following. They will type in delay 1000. There we go, we've put a delay in, and now if I run the code, let's clear the serial monitor so we can see the output, and you can see that our output is now running once per second. Now, this is fine if the only thing we want to do is print hello world at an interval of once a second. However, let's put a new line of text in. We'll just call it hello world 2, and I want this line of text to be printed every 2 seconds. Now, how do I do that? If I put in delay 2000, let's have a look and see what it now does. Clear the output. Hello world 2. Notice the timings on these things. Let's just stop the serial monitor scrolling. So the way this is working, if we look on the timer here, it was 1 second, because if we look at our code, we had a delay of 1 second. Then we printed hello world, we had a delay of 2 seconds. So we now go down to a 2-second delay here. And then we've got another 1 second gap. So the problem here is that because of the delay, this is now reading every 3 seconds, and this is now printing out basically every 3 seconds, because the two delays become cumulative. And this is the problem with delay. So on this course, you will not see delay, because it will absolutely ruin your code. Rather than being a shortcut to success, it will actually ruin your bigger projects. Now let's have a look at why. So if we go back to our sort of system diagram, remember how the loop works. Now with our loop, the idea is that we are constantly reading from our sensors, our inputs, and we are constantly controlling our outputs. And our logic code is making decisions based on the inputs and deciding what to do with its outputs. Now, the problem with delay, as soon as you get a delay, this loop stops. So in the little bit of code that we've been looking at, we serial print out some text. So we've sent something to a display. We then stop the loop. The loop does not move at all. It just sits there for 1 second. Then we send an output. Again, our second line of text. Then we wait for another 2 seconds. Then we can finally go back and we start again. But what it means is during that delay period, no other item can receive an output and you cannot receive any inputs. And this is why you see beginners struggling so much. And one of the classic things, when I see someone crying for help, you look down their code and you go, oh my goodness, it's full of delays. So on this particular course, we're not going to learn about using delay. We're going to use a much better way to time our programs. So going back to our code, I'm going to change the text here, and we're going to put 1 second interval. Then what we're going to do is change the next line of code, and we're going to call this 3 second interval. And then just to make life a little bit more exciting, we're going to have one here at a 5 second interval. We're going to get rid of the delay. And now we're going to get rid of this other delay. So the goal of today's lesson is I want serial print at 1 second intervals, a serial print at 3 second intervals, and a serial print at 5 second intervals, and I don't want any interference between these items. Now, thankfully, going back to the picture of our Arduino, somewhere within its sort of processor, there is a clock. Now, I don't mean a clock that is counting the hours of the day, but it's actually timing the time since the Arduino started. So that's since either the program was uploaded or the Arduino was turned on, and it is calculating that time very accurately and in very small steps. In fact, those steps are so small, it is 1/1000th of a second. So going to our language reference, the function that we are going to use today is millis. And the way that this is used is quite simple. Basically, you call this function and it gives a value, and then you can store it in a variable. So let's go back to our code window and get on and set this up. Now, if you think back to our previous sketch, we set up a variable and it was an integer. And that allows us to store a value between -32,768 and 32,767. Now think about milliseconds. That means for every second we are going to count to 1000, which means in less than 33 seconds the number that we have counted to is going to be bigger than, if you like, the variable box can hold. So we need a bigger box, and for that we're going to use a variable called an unsigned long. Now, once again, going back to the language reference, if we go down to data types, we see here the unsigned long. And when we look at this, it is an unusual variable. It will not store a negative number. It can only store a positive number, but look at the number that it can store. A value between 0 and over 4 billion. Those are some big numbers, but we're going to need numbers that large if we're going to store the number of milliseconds since the board started. So let's get this variable declared in our code. So going back to the sketch, I've now created my unsigned long. I've given it the name current millis. Now, as you go through these tutorials, you will get used to this particular variable, and this variable is always going to store the number of milliseconds since the board started. So let's take a copy of its name to make sure that we spell it correctly. Go down to the main loop. Let's get rid of that comment. And it's going to be equal to millis. So this is a function, as we saw, that returns the time in milliseconds since the board started. And now current millis, our variable, is going to equal that value. It's exactly the same idea as what we did in the last sketches, where we said my integer is equal to 2 plus 2, or my integer is equal to my int plus 34. So what this does is every time the loop goes round, right at the beginning of the loop, the first thing it does is it stores the current time in milliseconds. Now, just to show that that is working, what I'm going to do is I'm going to comment those lines out. And we're just going to put in here serial print line current millis. So that is now going to send the current time in milliseconds to the serial monitor. So it's uploaded, and as you can see, the number is increasing. So we're now capturing the time since the board started in milliseconds. Now we're going to use that value to create some timings within our program. So if we look at our goal for our program, the idea is that we want this string to be printed every 1 second. So we need a gap, if you like. We need to be able to work out every 1,000 milliseconds, we need the code to do something. So we need a variable to hold another time. Let's create another unsigned long. And we're going to call it timer 1 millis. And then we're going to create another variable, another integer this time. And I'm going to call it timer 1 delay. And we're going to give that a start value of 1000, because hang on, we misspelled that. What we want to happen here is obviously every 1,000 milliseconds, that's 1 second, we want something to happen. We want the line to print out. So we're going to use those two variables now in our main loop. So back down in the main loop, what we need to do is work out if 1,000 milliseconds have gone by. So what we can do is we can say if. Now hang on a minute, what is an if? Well, an if is a control structure. So again, if we go back to our language reference, if we scroll right down, you will come to structure and control structure, and one of those control structures is the if statement. And the if statement takes a condition and sees if it is true. If it is true, it will proceed. Now, what does that mean in English? So going back to our code, if checks a condition. So let's put some very simple conditions in. So we could put if 3 is greater than 2, then do something. So if the value of 3 is greater than 2, then it will do something here. If 3 is not greater than 2, then it won't do anything. Now, obviously, 3 is always going to be greater than 2, but when we are using a timer, of course, those values are constantly changing. So we're going to change this, and we're going to put in if current millis minus, and let's just get my spellings correct. We're going to take that variable down. So if current millis minus timer 1 millis is greater or equal, that is what that, if you like, that angle bracket followed by an equal. If that is greater or equal to the timer 1 delay, which we have set at 1000, so 1 second, then we want something to happen. And what we want to happen is we want a serial print out the current time in milliseconds. So let's get that uploaded. So the code is now uploaded, and I'm going to start the serial monitor. Let's stretch this up, because as soon as I start the serial monitor, the Uno will restart itself. So we're going to start the serial monitor and look at our output. There we go. Let's stop it there. So what has happened here? We have got these various items that have happened, and then all of a sudden we've gone to our main loop. Let's just scroll our code, and it has waited until current millis minus timer millis is greater or equal to the delay, which if you put your mouse pointer over, you can actually see the value that was set in it. Timer 1 delay was set at 1000. So we can see that nothing happened until 1000 milliseconds had gone by, and after that it constantly starts to print out the current milliseconds since the board started. So going back to our code, we have partial success. We got our 1000 delay, but it only happened once. We need it to continue to happen, and to do that there's a very simple line that we add, and we go timer 1 millis is equal to current millis. So let's think what's now going to happen. Current millis minus timer millis is greater or equal to 1000. So at that point, it's going to print out this line. But at the same time, it's now going to make timer millis equal to current millis. So when it goes round its next loop, it's going to go, oh, hang on a minute. This value isn't 1000 difference between them. Therefore, I've got to wait until that difference is greater or equal to 1000. So let's upload the code and see how it works. So starting the serial monitor, here we go. We get our initial information. Now look at that. We are seeing 1 second intervals, 1000 millisecond intervals. Now, if you can get your head around this very simple piece of code, you will be able to have some superb timing within all of your projects. Now, the goal of our code was to serial print this at 1 second intervals. So I'm going to copy that and paste it in there. Let us just delete that one out. And I'm going to leave the current millis in there as well so that we see it print correctly. Let's just upload that code. Start the serial monitor, and there we see it, 1 second delay, and we can see our 1000 millisecond difference between them. Now, the great thing about this code is that our loop is still spinning flat out. Because we haven't added delay, all it's saying is if at this point the time has got to a certain level, then do something. But if not, keep going, keep going, keep going. And here we have our time input. Has it got to that particular time? Yes. Now send the output. So we are now using time to control our code logic. Now, at this point, of course, we are just sending something to the serial monitor. It's not particularly exciting, but this is why learning this very simple piece of logic is so important, because once we've learned this logic, we will then be able to apply it to buttons, to sensors, inputs, outputs. This little bit of code can be used to control all sorts of things. So that is why this lesson is particularly important for, if you like, your Arduino programming career. Now, going back to our code, because we've been successful here with this timer, let's quickly create the timers for these other two items. So going back up here, I'm going to just copy this and create two more sets of variables. We will call one of them timer 3 millis with timer 3 delay, and that's going to be at a 3-second interval. We've then got a timer 5 millis with a timer 5 delay, and that's going to be set at a 5-second interval. So now coming back to our code, we don't need to call current millis again because it's created at the beginning of every loop. So all we need to do now is recreate this a couple of times. And we can change this to a 3, 3, 3, and 3. And then coming down here, let's do the same with the 5, 5, 5, and we'll put 5 in there. Just check that's all okay. That looks good to me. Let's give it a go and upload the code. So the moment of truth. Let's open the serial monitor. Our initial values. And here it comes. All our information is coming through. So what are we seeing here? So we've got our first 1-second interval at 1000 milliseconds. Another 1-second interval at 2000. At 3000 milliseconds, we've got a 1-second interval, but we've also got our first 3-second interval. Then we go back to 4000, which gives us another 1-second interval. At 5000, we get a 1-second interval, but we also get a 5-second interval. And then at 6000, we get a 1-second interval and our second 3-second interval. So at this point, we can see that our code is working really, really nicely and giving us absolutely perfect timings. Now, in the code, I've added some comments in. So I've tried to explain here just exactly what is going on in case you didn't get it. So let's go through it again. We have the current time in milliseconds that is taken at the beginning of every loop, and we subtract the old timer one in milliseconds from it, and we're checking to see, is that greater or equal, that's what that symbol is, than the timer 1 delay, which as you can see has a value of 1000. If that interval is greater or equal to 1000, we reset the value of timer 1 millis by making it equal to current millis. That way it's ready for the next loop when it's checked again by the next if statement, and then we're just printing out the value of current millis, and we're serial printing out our 1-second interval just so that we know that is what is happening. This is the 1-second interval. The code is then repeated for the 3-second and the 5-second interval. Now, if you want a bit of homework, what I'd say to you is create some more of these with different timings. Obviously, we are using quite big timings here. That's because if you're trying to read the serial monitor, the last thing you want is something going at 10 milliseconds or something like that. But as you can see, these times could be as long or as short as you want. Now, they could go down to 1 millisecond if we required that. So these can be used for all sorts of timings. and just get used to using this bit of code, because it's this method of timing that we will be using in every lesson and every project going forwards. And as we think about projects going forwards, in the next lesson we will start to use digital write and start to control our outputs. Let's get some LEDs and maybe some relays working. So look forward to seeing you in the next lesson.